Thanks for the introduction, Steve. And I just wanted to check that the audio is up for the videos. Great. So today I'll be talking about our work on creating animated stories with script-driven performance animation. And this is with Hari Subramonyam, Eytan Adar, and Mira Dontcheva. Hari, who's the first author, unfortunately couldn't make it to Berlin, so that's why I'm stepping in for him today. So animations are, of course, a really popular and long-standing art form, from classics like Felix the Cat to more modern cartoon series like our cartoon President. Artists have been using animation to convey ideas and to tell stories as well. Now, traditional techniques for creating animation, like cell animation where every frame is drawn by hand, or keyframing where the artist or the animator carefully poses the character over time, tend to be quite labor-intensive. But recent advances, even not so recent advances in voice and motion analysis, have enabled a different form of animation, one where the animator can just perform to drive the character by talking, moving their hands around, maybe changing their facial expression, as you see here. Now, this is really great for specifying the motion of characters, but that is only one small part of the overall workflow for creating animated stories. And typically, the first step is to write a script, and then you need to find and coordinate some actors to play the different characters. So this could involve getting them all into the same room, as you see here, or maybe trying to schedule them to perform in different locations and at different times. And then once you have the actors, they have to actually record those performances, and this often involves multiple takes so that actors can fix their mistakes or also layer performances on top of existing recordings. So this typically produces a lot of individual recorded takes, and these finally have to be edited together to create an actual animated result. Now, the problem is that all of these steps, in addition to each one taking some amount of time, tend to be done in isolation and typically with separate tools. And this introduces a lot of friction into the workflow that makes it hard to create and iterate on animated stories. So, for example, if an author first writes a script, they may have to wait a really long time, many hours or even sometimes days, to be able to coordinate the actors, record the performances, and then edit together the final animation, just so that they can see, get a sense for how that script actually plays out. And even worse, if they make any edits to the script, that typically invalidates a lot of this downstream work, which then has to be redone from scratch. So, this is clearly not ideal. It introduces a lot of latency into this feedback cycle. So in our work, we take a different approach, which we call TakeToons, that tries to lower some of these barriers between these steps, and as a result, integrates and interleaves the writing, performing, and editing steps of this workflow. And the main idea here is for us to annotate scripts with markup that indicates how animations should happen, and this makes it easier to coordinate and record performances, as well as allows us to automatically edit together those recordings into a final animation. And as a result of this, once the author creates one of these annotated scripts, it takes much less time for them to get an initial rough cut for feedback. And if they want to make some edits, many of these can be automatically propagated through all the way through to the final animation, which means that much of this downstream work does not have to be redone. So our approach leverages advances in both performance-based animation as well as some recent systems on script-based authoring UIs. And the main new contribution of our work is in developing a script-based editing approach for creating animated stories with performance. Okay, so let's take a look at how the TakeToons workflow actually goes. So to start, we assume that artists have already created and rigged the necessary artwork so that the characters and scenes are ready to be animated via performance. Okay, so given this rigged artwork, the first step is to write a script. We extend Fountain, which is an existing markup language for script writing that already supports indicating what the scene is, in this case a studio, which character is talking, so Jill is the red monster. And then in addition, we add animation markup that allows authors to specify animation events. So for example, this markup generates or specifies the little heart animation you see appearing above the character's head. And this one makes a postcard of Phoenix appear behind the character as the character is talking about Phoenix. And we support a whole bunch of other animation markup as well for, let's say, changing the camera angle, changing the character's pose, making explosions, you name it. So given this script, the actor can then go ahead and perform using voice and motion capture. And as you can see on the screen here, to help help the actor keep track of where they are in the script, we show a teleprompter view next to a live preview of the animation. Okay, so with this view, once the actor starts performing, their voice and motion are automatically applied to the character. And in addition, any of those animation events that were marked up in the script, they get triggered at the right times based on what the actor is saying. Since it's not always convenient for the actor to be right in front of a keyboard and mouse, TakeToons supports voice commands for controlling the recording. So let's see how this all looks for recording the first couple lines of this story.
Start recording. Welcome to Chat with Joe. It's almost spring, and it's my favorite season of the year. I'm from Phoenix, and spring is that wonderful time before the scorching summer.
Okay, so TakeToons also supports multi-actor workflows. So in this story, there's Jane the scientist and Evans the robot. And let's say the actor wants to first just record Jane.
Let's record Jane. I am Jane, and I love building robots. And I also like to travel.
Okay, so to give Jane some context for her next line, TakeToons automatically synthesizes the other character's part.
My data shows Japan is nice this time of year.
Japan sounds great. We can even make a documentary.
Okay, and now when the other actor, my other co-author, wants to record the part for Evans, then TakeToons automatically plays back the existing recordings for Jane at the right time.
Let's record Evans.
I am Jane, and I love building robots. And I also like to travel.
My data shows Japan is nice this time of the year.
Now, while these performances are being recorded, TakeToons automatically assembles a timeline with different takes for all the different characters. And this timeline can be treated as a rough cut so that the author can go ahead and tweak and refine it if necessary. Okay, so now what if I've recorded that original recording and I want to change something about the timing? So in this original recording, right after Evans says his last line, he transforms into this film bot. So that's what this looks like.
We can even make a documentary.
Sounds like my kind of thing.
Okay, so what if I like that, but I want that transformation to happen before he says his last line? Well, I can just go ahead and go back to the script and edit the markup, as you see here, to put that action in front of the last line. And now when I save it, without having the actor re-record the performance, we get that update in the final animation.
Sounds like my kind of thing.
So in addition to what I've already shown you, we also support some other interaction modes like layering of performances as well as retakes, but I'll refer you to the paper to see the details of those things. Let's take a quick look at how some of TakeToons works under the hood. So the overall system architecture looks like this. Starting with an annotated script, TakeToons automatically parses this into a story model where the nodes represent the marked up animation events. And then as the user performs, the story controller maps those performances into that story model. Now finally, to create the animation, to create the final animation, an animation engine converts the story model into the final animated result. And in our case, we use Adobe Character Animator for that engine. Now, since the story model and the controller are the main contributions of our work, I'll say a few more words about those. So the story model represents the annotated script as a directed acyclic graph where this backbone of speech nodes represents each line of the dialogue, and then all these other nodes represent the various other animation events that are marked up in the script. So for example, the lip sync and face nodes represent the mouth and facial animation of the character, and then these trigger nodes represent those predefined animation events like the heart animation that appear at different times in the script. Now, the edges here represent temporal relationships. So this line of speech, for example, occurs before this one, and all of these animation events have to occur at the same time. The job of the story controller is to map the actor's performance into these nodes of the story model. So, for example, when the actor starts the recording, The controller arms the appropriate nodes for recording based on the current position of the playhead, and then maps different parts of the actor's performance to these different nodes. So, for example, an audio recording of the vocal performance is mapped to the speech node.
I'm Jane, and I love building robots. I also love to travel.
And then the voice and motion of the performance is mapped to the lip sync and facial animation of the character, as you can see here. And then finally, animation events like Jane putting on her goggles are triggered at the appropriate times in the performance. So for the next few slides, I'll use this visualization to indicate the story model nodes being filled up by a recorded performance. So let me explain some of the basic recording modes that the story controller supports. So the default mode, when the user just says start recording, is to walk through each line of the dialogue one at a time. And so what the controller will do is arm the corresponding nodes in sequence so that the actor can record first Jane, and then Evan's line, and then Jane's second line. Now, as you saw earlier, we also support single character recording. So in this case, the actor wants to record just Jane. So here what the controller does is first arm and record Jane's first line, and then play back the existing or synthesized recording for Evans in that second line before moving on to Jane's next line and arming and recording those nodes. So in general, the controller, by arming and playing back different combinations of nodes, can support a variety of different recording modes. In particular, we also support layering, where an actor layers a performance on top of some existing recordings, as well as retakes. But again, I'll refer you to the paper to see the details of how the controller supports those other types of modes. Let me say one last thing about the story model, which is that it also provides a way of encoding and automatically propagating many edits to scripts. So for instance, if I want to delete or move a speech node or a triggered animation event, well, the corresponding change can just happen inside of the story model. And if I want to change one of the triggers, let's say I want Jane to not put on a pair of goggles, but to put on a welding mask, well, then I can just change the type of that trigger node to represent that change, that edit as well. So using TakeToons, we've created 3 short animated stories with different characters, scene changes, camera cuts, as well as a variety of different animated effects, as you can see a little bit here. But the paper video includes all of these animated stories in their entirety with audio. Okay, so to get a little bit of preliminary feedback on our system, we asked four professional animators to try out TakeToons, and the overall response was very positive. They definitely felt that TakeToons could streamline a lot of their production workflows. They also said that for simple animations like kids shows or maybe certain types of explainer videos, that the raw, unedited TakeToons output could probably be pretty close to the final quality. They also felt that for larger production teams, with many different people doing all these different tasks, that TakeToons could help to coordinate all those different tasks across the writing, performing, and editing phases. As a result, they generally felt that the small kind of upfront cost of adding annotations, these kind of animation markups, to the script was worth that cost. They also had some suggestions for improvements. All of them thought that the teleprompter should really be on the animation stage, so you only have to look in one place. Some suggested maybe having some real-time guidance for how the vocal actor should perform the script, maybe like a bouncing ball or something like that. And then some also suggested having a visual interface for adding annotations to the script, maybe like dragging and dropping an animation event onto the appropriate part of the text. So in conclusion, I presented our work on integrating and interleaving the various parts of the animation production process via an annotated script and performance animation. TakeToons does have some limitations that point to some interesting directions for future work. So one is that we're really focused on very tightly scripted kinds of animations. And it'd be really nice to be able to make that more flexible so that the user could, or the actors could improvise a little bit more and not be so tightly scripted. In addition, our system currently automatically propagates certain types of script edits, but sometimes if you change that story model too much with existing recordings, you can get some inconsistencies or discontinuities in the various animation segments. So it'd be nice to be able to automatically smooth some of those. But probably the broadest direction for future work, the one that seems most exciting to us at least, is trying to extend the approach that we've taken with TakeToons for animated stories to some other domains, other types of scripted content, like, for instance, live lectures like what I'm giving right now, or maybe explainer videos. And so with that, I'm happy to take questions. Thank you.
I have some questions. Have you thought about things in which you're actually tracking the body and not just the face, so people could, do things with their hands?
Yeah, I mean, as I said, right now we're using this kind of existing piece of Adobe software for doing the performance animation, which only supports face tracking and voice analysis. But it would definitely be really nice to be able to support body tracking, full body motion as well. I think that definitely fits within the model of what TakeToons is trying to do.
And also you mentioned directors wanting to use it for larger productions, and that makes me think of parallelism, because what you presented had first one actor went, then another actor went, and maybe at the expense of additional actor time, you could have multiple actors at the same time recording, and then the next time an actor retakes, they do it not with the automated voice, but with the actual voice of someone else. Yeah,
so the current model is a little bit sequential, and that's in part just an artifact of the fact that the performance animation system right now only can listen well to a single character with a single microphone at a time. We could support what you're talking about right now if each of the characters was kind of mic'd up separately. They could be co-located but and talking in parallel, but they would have to be mic'd up separately and sound isolated a little bit. But yeah, I think obviously a lot of times when people are doing these types of vocal performances, they do have multiple actors in a room so they can play off of each other. And so I think that would be a really natural thing to be able to support.
But also for people who are not co-located.
Yes, that's right.
You didn't have to fly in to be co-located.
Yeah, that's true. That's a good point.
And then one more question. So you mentioned the idea of replacing the goggles with the mask or something, and that's sort of like a replacement, but you could also record goggles and masks and all sorts of other things, so you could make some maybe runtime choices as to which one you're going to use to make it differ from one playback to another.
So just to clarify, I mean, in those cases, those animation cycles are already predefined, so you could actually right now kind of choose between them in real time, which I think would be an interesting extension. So see one question.
Oh, good.
Yes, please. So I noticed that within your workflow, you started out with the classic script-based representation, text-based, and I was wondering, now that you're adding in commands into the script, have you thought about different representations that might suit those commands? Because now the script is not necessarily as linear in its representation anymore.
Yeah, that's a good point. I mean, in some ways, we kind of showed that visualization of the story model as just like an internal explanation or a way of explaining what's going on under the hood. But that is actually what is happening in the representation, which is a lot less linear, as you're saying. So I think some of the suggestions we got from the animators to kind of have a more visual interface for annotating the script could go down those lines, where we could expose maybe more of that story model structure, but still kind of showing the lines of dialogue very clearly, make it easy for them to write with text as well. So I think a combination would be a really interesting thing to explore.
Cool. Thank you.
Great. Thank you.